Imagine looking out at the ocean, the vast expanse of blue stretching endlessly before you, and then, suddenly, you notice the water turning a strange reddish-brown color, almost as if the sea itself is bleeding. This eerie and captivating phenomenon is known as a red tide, a natural event that has intrigued and alarmed people for generations. It might look like someone poured red dye into the water, but the truth behind this spectacle is far more complex and fascinating. Red tides are caused by tiny microscopic algae that live in the ocean. These algae, often called phytoplankton, are like tiny plants that float near the surface of the water. Under certain conditions, these algae can grow out of control, creating massive blooms that can stretch for miles and miles, painting the ocean in shades of red, brown, or even green. While some algal blooms are harmless, others can produce potent toxins that are dangerous to marine life, causing fish kills and affecting the health of other sea creatures. These toxins can even pose risks to humans, leading to respiratory issues and other health problems. The mystery of red tides has puzzled scientists and sailors for centuries. Ancient mariners often recorded their encounters with these strange colored waters, sometimes attributing them to supernatural causes. Today, researchers are working tirelessly to understand the complex factors that lead to red tides. They study water samples, deploy oceanic sensors, and use satellite imagery to track and predict these events. Understanding red tides is crucial for protecting the health of our oceans and the creatures that live in them. By learning more about these phenomena, we can develop better strategies to mitigate their impacts and safeguard marine ecosystems for future generations. Communities around the world are also playing a vital role in addressing the challenges posed by red tides. Through beach cleanups, educational programs, and conservation efforts, people are coming together to protect our precious marine environments. The beauty and diversity of our oceans are worth preserving. By understanding and addressing the mystery of the Crimson Tide, we can ensure that future generations will continue to marvel at the wonders of the sea. Red tides might seem mysterious, but the science behind them is fascinating. These phenomena are caused by the rapid growth of microscopic algae. The culprits are tiny algae called dinoflagellates. These single-celled organisms are incredibly small, yet they have a massive impact on their environment. These single-celled organisms are a normal part of the ocean's ecosystem. They coexist with a variety of marine life, contributing to the delicate balance of the underwater world. Like plants, they use sunlight to make food through photosynthesis. This process allows them to convert sunlight into energy, sustaining their growth and reproduction. Under certain conditions, dinoflagellates can multiply rapidly, creating a bloom. These blooms can spread quickly, covering vast areas of the ocean in a short period. Factors like warm water temperatures, excess nutrients from runoff, and calm seas can trigger these blooms. Agricultural runoff, in particular, provides an abundance of nutrients that fuel the growth of these algae. When these conditions align, the dinoflagellates thrive, leading to the formation of a bloom. The calm seas allow the algae to remain concentrated in one area, intensifying the effect. When millions upon millions of dinoflagellates gather together, they can change the color of the water, creating a striking visual effect. This results in the reddish-brown hue of a red tide. These blooms can be so dense that they are visible from space, highlighting the sheer scale of these natural events. Not all red tides are harmful. Some dinoflagellate species don't produce toxins. However, some species produce toxins that can be harmful to marine life. These toxins can accumulate in shellfish like clams and oysters, making them unsafe for humans to eat. Fish can also be affected by red tides. The toxins can damage their gills, making it difficult for them to breathe. In severe cases, red tides can lead to massive fish kills, devastating local ecosystems. One of the most well-known examples of a harmful red tide occurred in Florida in 2018. This event captured the attention of scientists, environmentalists, and the general public alike. A massive bloom of Karenia brevis, a toxic dinoflagellate, stretched along the Gulf Coast for months. These microscopic organisms produce potent neurotoxins that can have severe effects on marine life and human health. The bloom caused widespread fish kills, with tons of dead fish washing up on beaches. The sight of lifeless marine creatures scattered along the shore was both heartbreaking and alarming. The economic impact on tourism and the fishing industry was devastating. Beaches that were once bustling with tourists became deserted, and local businesses, especially seafood markets, suffered significant losses. The red tide also released toxins into the air, causing respiratory problems for people living near the coast. Residents and visitors experienced symptoms such as coughing, sneezing, and eye irritation, leading many to wear masks for protection. The 2018 Florida red tide was a stark reminder of the potential devastation these events can cause. It highlighted the need for better monitoring and management of coastal waters to prevent such occurrences in the future. Scientists and researchers worked tirelessly to understand the causes and effects of the red tide. They collected water samples and analyzed them in labs, hoping to find solutions to mitigate the impact of future blooms. Community meetings were held to discuss the red tide's impact and to find ways to support affected businesses and residents. Local news outlets interviewed residents, capturing their concerns and hopes for recovery. Volunteers played a crucial role in cleaning up the beaches, removing dead fish, and raising awareness about the environmental issues caused by red tides. Their efforts were a testament to the community's resilience and determination to restore their beloved coastline. While the 2018 red tide was a challenging period for Florida, it also brought the community together and underscored the importance of protecting our oceans. Today, efforts continue to ensure that Florida's beaches and marine life can thrive once again. Section 5. Suffocating the life out of the sea. Red tides can have a suffocating effect on marine life. When the dense blooms of algae die and decompose, they consume vast amounts of oxygen in the water. This process, known as eutrophication, creates dead zones where fish and other marine organisms cannot survive. The lack of oxygen can lead to mass die-offs of marine life, disrupting the delicate balance of the ecosystem. Coral reefs, seagrass beds, and other important habitats can be severely damaged by red tides. Section 6. Cascading consequences, from seabirds to seafood. The impacts of red tides extend far beyond the ocean's surface. Seabirds that rely on fish for food can be poisoned by eating contaminated prey. Marine mammals like dolphins and manatees can also be affected by red tide toxins. Red tides can also impact human health. Eating shellfish contaminated with red tide toxins can cause severe neurological and gastrointestinal illness. The toxins released into the air can also cause respiratory problems, especially for people with asthma. Section 7. Can we stop the red tide? Red tides are a natural phenomenon, but human activities can exacerbate their frequency and severity. Nutrient pollution from agricultural runoff, sewage, and industrial discharges can fuel the growth of harmful algal blooms. Climate change is also playing a role. Warmer water temperatures create favorable conditions for dinoflagellate growth. As the planet continues to warm, we can expect to see more frequent and intense red tide events. Section 8. Early warning systems, our eyes on the ocean. Scientists are working hard to better understand and predict red tides. Early warning systems using satellite imagery and water quality monitoring can help alert coastal communities to the presence of harmful algal blooms. These early warnings give people time to prepare, closing beaches, issuing health advisories, and taking steps to protect marine life. The faster we can detect and respond to red tides, the better equipped we are to mitigate their impacts. Section 9. Reducing pollution, keeping our waters clean. Preventing pollution is crucial for reducing the occurrence and severity of red tides. Reducing nutrient runoff from farms, lawns, and urban areas can help limit the amount of excess nutrients entering our waterways. Upgrading wastewater treatment plants to remove more nutrients from sewage is another important step. By keeping our waters clean, we can create a healthier environment for marine life and reduce the risk of harmful algal blooms. Section 10. The future of our oceans, a call to action. Red tides are a stark reminder of the interconnectedness of our planet. What we do on land can have a profound impact on the health of our oceans. Protecting our oceans from harmful algal blooms requires a collective effort. Governments, scientists, businesses, and individuals all have a role to play in reducing pollution, mitigating climate change, and protecting our marine ecosystems. By working together, we can ensure that future generations can enjoy the wonders of a healthy ocean. On Section 11, Our Blue Planet, Our Shared Responsibility. The mystery of the red tide is a reminder that we still have much to learn about our oceans. As we continue to explore and understand these complex ecosystems, we must also take responsibility for their protection. Our actions today will determine the health of our oceans for generations to come. Let's work together to ensure that our blue planet remains a vibrant and thriving place for all life.